Okay, so 9.2, graph and write equations of parabolas. Okay, so we have dealt with parabolas in the past. What forms have we dealt with parabolas in?
A something, is it AX plus something?
Ax squared plus bx plus c in standard form. What are the other two forms that we've dealt with parabolas?
Is it with radicals?
Those are rational functions. What are the other two forms parabolas can be in? It has to do with what you're graphing specifically on them. What does every parabola have? Graph it, you have to have this point.
A vertex.
So there's a vertex form, and then there's also intercept form. Today we're gonna look at four.
Oh, yeah, I know what that is.
Okay, today we're gonna look at four different equations that deal with graphing parabolas when they're not in any of those forms,
Oh, that's, okay.
okay? When they're not in simple forms for us. So, when we talk about graphing parabola now, we're gonna have to have three things, well, four things really to graph these parabolas. One, you need a vertex.
Right,
Two, you need something called the focus.
right,
The focus is always on the inside of the parabola. So the parabola will open up and the focus will be on the inside of it. Then you need something called the directrix. The directrix is a line that is parallel to the parabola. Now listen, the focus and the directrix are equidistant from the vertex. The focus and the directrix are equidistant from the vertex.
wait, but, oh, I should, never mind, okay.
Remember, I just graphed these, so they might not look
Okay, that's why I
perfect.
was confused.
They might not look perfect, okay? So the focus and the directrix are always equal distance from the vertex. Then you have the axis of symmetry, which goes straight through the vertex, the focus, and the center of the directrix, okay? So that's what we are going to start labeling when we graph. There are four ways we can graph this. You can graph one facing up, one facing down, one to the right, and one to the left. If they are facing up or down, they have the equation of x squared equals 4py. The reason it's x squared is because when you graph something that is vertical, it's x equals, yes?
Yeah.
Okay? So when they are vertical, meaning they're facing up or they're facing down, it's x squared equals 4py. We're going to talk about what that 4p and y are in a second, okay? So it's x squared equals 4py. When it is facing up, the p is greater than 0. When it is facing down, the p is less than 0. That's how I know what's going on, okay? Now, the focus on all of these today, that we're talking about today right now, the vertex is 0, 0, and 0, 0. It's the standard form of them, okay? The focus is then 0p or 0, negative p. I should say negative p.
And up will be positive P and down will be negative P.
Correct. It's gonna be listed like this, 0p and 0p, because what happens is your p is negative here, yes?
Yeah,
Your p is positive here. So we don't write this as negative p because this is negative already. That's why it's facing down.
does P just mean like your point?
No,
Oh.
we're gonna talk about what it is in a little bit. Okay, and then you have your directrix always, which is equal distance from your vertex, okay, as your focus is. When you face left or right, your equation says y squared equals 4px. The y and the x switch places on these. Okay, so if it's left and right, it's y squared equals 4px. Your vertex still on these today are 0, 0. Your focus are still p, this time it's p0, p0. See how that switches? The p is in the,
So there's not
X spot.
So it's not a negative P?
well, remember this one's negative already.
Oh, okay.
Okay, so once again, this p has to be less than 0 to face left. This p has to be greater than 0 to face right. Then I have my directrix. Here it is broken down in a little bit of a different form instead of on a graph. If I have the equation x squared equals 4py, my focus is 0p, my directrix is y equals the opposite of p, and my axis of symmetry is vertical. example would be x equals 0, okay? If my equation is y squared equals 4px, my focus becomes p0. My x equals the opposite of p, my directrix. And my graph is, my axis of symmetry is horizontal, example would be y equals 0. Okay, so then we get here where it says graph x equals negative 1/8 y squared. Can I graph that?
Yes.
What do you, how?
Once you have to get it to, like a form,
Yeah, what do you mean by that?
you have to have y squared.
You would have to get it to say y squared equals.
Yeah.
How do I get rid of that negative 8?
Multiplied by 8.
Multiply it by negative 8,
Yeah.
okay? So if I multiply both sides by negative 8, okay, then I get this. I get y squared equals negative 8x, okay? Now, I can graph that equation. Is my graph gonna face left, right, up, down?
It's gonna face,
First of all, let's establish, is it up, down, left, or right?
left to right.
Left or right, so it's one of these two. Now, how do I know what my P is? Because my P is what tells me if it faces left or right, correct?
Mm-hmm.
Okay, do you see how this says negative 8x? Do you see how this says 4px? 4px. What do you think I'm gonna do with negative 8 to figure out what P is?
Plug it in.
Nope,
Divide by two.
divide not by 2, divide by
4.
4. Because the 4 is already multiplied into all these equations.
It is?
It is. Okay,
Okay.
so you always have to divide by 4 to find your P. Okay, so your P equals negative 8 divided by 4, which is negative 2. Negative 2. Now, is it facing left or right?
Left.
Left. In this case, my vertex is what in this case? We haven't learned anything else, so it's
0, 0.
0, 0. So I know I can graph this. Okay, my P equals negative 2, meaning my focus, and I have to label all these things, focus, directrix, axis of symmetry. My focus would then be, what is my point for my focus?
Negative 2, 0.
Negative 2, 0. So I go ahead and graph that, okay? What's my directrix?
Isn't it, well,
Your directrix, when it's this type of graph, is x equals what?
the opposite of P?
The opposite of P, so what would that be?
2.
So x equals 2, so I come over here. Now, do you see how these are equal distance from the vertex?
Mm-hmm.
Okay, so come over here and grab that. So then, how do I graph the rest of this? I simply plug in a point and reflect it over, because this is my axis of symmetry, right?
Oh, wait, it equals 2 because.
Because the rule is x, your directrix is x equals the opposite of P.
Okay.
P is negative 2, so it equals 2. My axis of symmetry is then what?
You said it was 0.
Not,
Oh.
yeah, on this one it is, it's y equals 0. Good. Okay, now, I'm gonna plug in a point. If I'm you, since my vertex is 0, 0, and I know it has to face this way, I'm plugging in negative 1 to start. Or not negative 1, I'm sorry. Here's where it gets tricky. This is y squared equals, yes?
Oh, I see what you're saying.
So I need to plug things in, okay,
So do you want,
to the x to get the y out, correct?
do you want like negative numbers at this point?
Yes, I want negative numbers because it has to face this way. So I'm going to plug a negative 1 in here, okay? Y squared equals negative 8 times negative 1, so you get y squared equals 8, yes?
Yeah.
You are going to have to do this on your calculator. What is the square root of 8? You cannot do this homework without using your calculator.
2.8.
Okay, and how many answers do you get when you take the square root of something?
2,
So you have positive and minus negative 2.8, yes?
yeah.
So I go to -1, and I go up to 2.8, and I also go down to negative 2.8, and now I have my parabola. Okay? You have to take it step by step. I'm gonna give you one more example of if they give you a graph, how do I come up with an equation, okay? And then, like I said, we're going to do this tonight and tomorrow. Okay?
Weird.
It is weird, it takes a while to get used to. And, yeah. Okay, let's say that you have this. They give you a very simple graph. Okay, here's this, the graph opens like this. They tell you that this is your vertex. And then they have they have this labeled as your directrix. Create an equation of that graph.
Well,
First-
Ooh, that's hard.
First, we establish what?
the vertex,
Well, okay, the vertex is what?
0, 0.
0, 0.
Oh, then,
Okay, but now we need to establish which equation
Oh.
we're using in the first place. So is it x squared equals 4py, or is it y squared equals 4px?
y squared equals 4px.
It's opening left or right?
Oh, x,
All the
x
squared.
squared.
It would be x squared equals 4py. Okay? X squared equals 4py.
Okay, that's not too.
Okay, so the only thing I need to find is my p to create an equation. How can I find my p? They didn't give you,
Multiply.
No, but wouldn't you wanna use the directrix? Like,
yes, you wanna use your directrix. They didn't give you the focus, and you know your focus is p equals whatever,
Mhm.
right? Your directrix is what compared to p?
Equidistant, wait.
Well, this point right here is what on your directrix? What point is that?
Negative 3.
-3. So my directrix, right, equals -3. And how does p compare to -3?
It'd be the opposite.
It's the opposite, so my p is
3.
3. So I plug that in. X squared equals 4 times 3 times y. What's 4 times 3?
12.
There's your equation.
Okay.
X squared equals 12y. You always multiply it back in, okay? X squared equals 12y. That's why we're gonna spend a couple days on this, because we gotta get this pattern in our head. If we don't get the pattern in our head, we're gonna struggle a bit, okay?